Hi there. All right, this is grade 6, unit 1, lesson 12. And in this lesson, students are going to learn what is surface area, and they're going to begin figuring out the official technique, the official formula for how to find the surface area of rectangular prisms. That's what we're going to limit ourselves today. Basically, boxes, and find the surface area of those boxes. So let's get started. So this lesson is kind of unique in that it starts off with a nice video. It's a classic video by Andrew Stadell where he is covering a big, huge cabinet with a bunch of sticky notes, and the students are supposed to watch and make an estimation. And that's the kind of like that physical reminder of what is surface area. Oh, it's the Post-its that are going around and covering the cabinet, which of course is a rectangular prism. And then students are going to, down here, the students are going to dig deeper into their that observation and really come up with some actual estimations, really strong estimations of how many Post-it notes are going to be needed to go around. Now, parents and teachers, this is that experiential opportunity for students to grapple with the meaning of a surface area. How many Post-it notes does it take to cover the cabinet? And we're going to let students grapple with this as they work on finding their developing an understanding of surface area. Getting the right answer of how many Post-its is not the important part. It's really developing an understanding of what surface area means. All right, and so then we're finally going to get into actually using snap cubes to really do surface area work, right? Now, I'm going to give you a heads up. This link for me did not work today, so I had to find it. So let's take a look at that on the screen right here. I had to find it. Here's the URL right here, and it's case sensitive, so you might need to type that instead. It just, for whatever reason, the link didn't work for me from the Illustrative Math actual website. But here you go, and you can grab this little red dot. Let's go. You can grab the red dot. In theory. There we go. And you could grab that red dot and put it anywhere. You need to click on that red dot to decide whether you're going to move. Oh, I see. Got it. To decide whether you need to move it vertically or horizontally. And so I think, let's see, do I have it right? Whoa. Oh, there you go. Look at that. And I'm just building it. Okay, so to be honest, this GeoGebra applet is beautifully made by my friend Jen Silverman. But to be honest, I'm struggling with how to, well, I guess I'm getting better at it now. Look at that. Woohoo! So I'm going to be playing with that. Now, let's go back to the problem so that we can see how we're going to use the GeoGebra applet to solve the problem. So let's go back to the screen here. It says here is a sketch of a rectangular prism built from 12 cubes. It has 6 faces, but you can only see 3 of them in the sketch. And now we're being told that this surface area is 32 square units. And it says you have 12 snap cubes from your teacher, or you're using the GeoGebra applet, right? Because there it is right there. Except that link didn't work for me. So I already showed you the URL. Use all of your snap cubes to build a different rectangular prism with different edge lengths than shown in the prism before. So how many faces does your figure have? And what is the surface area of your figure in square units? So here we go. We're going to go into real life mode here. Now here's our original rectangular prism. It matches the original on the picture. And you know what I'm going to do is I'm just going to take it apart and I'm just going to insert it like this. And here is my new rectangular prism. And it's going to look a little bit different. It's going to have, let's see, it's going to be 2 across, 6 high, and only 1 deep, right? So that's what it's going to look like. So I'm going to try and draw this the best I can on my screen. All right, so now first off it says how many faces does your figure have, and the answer is 6. How do we know it's got 6? It's got a front and a back, and then it's got a side and another side, and then it's got a top and a bottom. So front and back, side to side, top and bottom. All right, there's our 6 sides that it has. So I'm going to write that down here, 6 sides. Now it says, what is the surface area of your figure? All right, so now as we look at this, and think about your Post-it notes, that each of these little squares, I'm not talking about cubes. I'm not talking about a cube. I'm talking about the squares, all right? The real flat Post-it note shape thing. So right here, wha-bam, I'm talking about this square and this square and this square. So this cube is going to be counted multiple times because we're going to be thinking about how many Post-it notes does it take to cover this cabinet, right? So if I'm looking at the front, I'm going to think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 Post-it notes on the front, 12 Post-it notes on the back. So that's 12 plus 12. So let's write that down. So 12 plus 12, because that's the front and the back, plus, now we're back here, and we're going to go side and side. Well, this side right here, 1, 2, 3, 4, 5, 6. So this side, 1, 2, 3, 4, 5, 6. So that's 6 and 6. So 6 plus 6, and that's the left side and the right side. Plus, now we have to do the top, and that's 2, and the bottom is 2. So that's 2 plus 2 for the top and the bottom. T and B. So now all we have to do is add them all together. And let's get back to their screen. So 24, whoa. So that's 24 plus 12 plus 4, which is, oh gee whiz, 36 plus another 2. So that's 40. So that's 40 square Post-it notes, square units. And that's what's interesting is that square surface area is different from the original square units of the surface area. So it turns out when you change the shape of your prism, you might change, I don't know if it's definite, you might change the surface area. You definitely do not change the volume. It's the same volume. All right. So anyway, that was a cool problem. So let's get going on this. Now down here it says we were supposed to draw our figure on isometric dot paper. Ooh, dang. Okay, so what is that going to look like? Let's change it to a little thicker pen, and let's go with green. And remember, it was 6 units tall. So I'm going to see 1, 2, 3, 4, 5, 6 units tall. And it was 2 units wide, so it's going to look like that. So that's the front. And I guess I could go backwards like this. 1, 2, 3, 4, 5, 6. And there are our sides. And now I need to do the top. And there is my figure. All right, and so that kind of matches what we were talking about. That's exactly what I was aiming for. There, woohoo! And so now you can kind of see, I would just go a little bit of bonus. So this front part, oh, let's make it in purple. This front part right here, that's our surface area of 12 units. And then, oh, let's choose a different color. Let's do red. The red right here is our 6. And then let's do blue as our top. And that blue has a surface area of 2. And so if we were to add those, all of that together, let's see, 12 plus 6 is 18, plus 2 more is 20 square units. But that's just for the fact that we can only see 3 sides, right? We can only see the front, we can only see one side, and we can only see the top. Each of those has a partner. This front has a back here. this top has a bottom down here, and this side has a partner on this side, right? So we would take that 20 times by 2, and that's how we got our 40 square units. So that's beautiful. That's really cool. We could do the summary cool down problem, but really the big key thing is we want to be focusing on faces, which is the front, the back, the left face, the right face, the top face, and the bottom face. Really, that's a better word. I should have been using that word as we think about it. That word was an important word, face. I kept talking about sides, and that's true. But face is a better word for it. And then surface area is really how many Post-it notes are you going to use to cover up your cabinet. All right. And so now let's do some practice, and we'll kind of whip through this practice because we don't need to do all the problems. What is the surface area of this rectangular prism? So let's take a look at, first we've got this front side right here. I don't know if that's the front or if it's the left or if it's the top. It doesn't really matter. So let's call that the front surface, right? No, front face. Let's call it the face. So the front face, and I will do it in blue. So that front face, what is the surface area? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that front has a surface area of 16 units, has an area of 16. Let's do the green for the top. Let's do that. So that top is up here, and that's going to look like 1, 2, 3, 4, 5, 6, 7, 8. So that green has an area of, what did we say, 8. And then we could do the red as this face right here, and that has an area of 1, 2, 3, 4, 5, 6, 7, 8. So that front has an area of 8. And so those are the three sides that are visible. So we're going to add that together. 16 plus 8 plus 8 is 32. Trust me. Actually, the way I did it, 32 is, this is 8 and 8. This is 8 and this is 8. So we had 4 8s. So 8 times 4 is 32 square units. Now, but that's only for the three sides that are visible. So now we have to multiply that by 2 because every side has a partner. Every face has a partner. So that's 64 square units. So there we go. Wha-bam. All right, so we're going to keep going here. It says, which description can represent the surface area of this trunk? The number of square inches that cover the top? Nah. The number of square feet that cover all of the outside faces? Ooh, that's sounding pretty good. But let's keep going. The number of square inches of the horizontal surface? No, that's because we have to do the whole thing. Not just the horizontal, but also the vertical. All right, so, and then, so that's not it. That's definitely not it. And then the last one, the number of cubic feet that could be packed inside the trunk. Nope, that's definitely not it. So there is our correct answer, the surface area of that trunk. So which figure has a greater surface area? Oh my goodness. So an idea, so parents and teachers, what you might want to do is we're going to go back to the cubes and stuff. You might want to just take your cubes and try and build them. And what's the harm in letting students use cubes to build these figures and then count the answers, you know, count the surface area. So there's no reason we can't just use our cubes, right? So consider it, man. Just let students play with their cubes, play with the cubes and get the answers that way in that concrete world before forcing them to have to use pictures and formulas and stuff. So there's nothing wrong with that. So we're going to go back here. But which one has a greater surface area? So if we're going to count the yellows for the red, for figure A. So there's 5 yellows, but we can see that there's a backside that is going to also have 5 yellows. So there's our answer there. Now let's talk about the greens. So I got a green, and a green. Well, let's just do the whole thing. So 1, 2, 3, 4, 5, 6. So we're kind of going down the top inside of the L. So that's 1, 2, 3, 4, 5, 6. So that's 6. Now the sides, the two sides that you cannot see is going down, and that's 3, and going on the bottom is 3. So that's 6. So adding that together, we're going to get 22 square units. That's what I'm going to go with. That feels about right. So now we're going to take a look at B. And we see that 1, 2, 3, 4, 5 plus the bottom is the identical 5. Now, going around, this is going to be tricky. We have to count all the faces going around this figure. And I could see that, let's see, like this cube right here, I already counted the top, I already counted the bottom. So now what we need to do is we need to think about the kind of this outside part right here. So it's 1, 2, and then the back side is 3. So this guy has 3, this guy has 3, this guy has 3, and this guy has 3. So that's 12, because 4 times 3 is 12. So I got 22, and ooh, the way I'm looking at it, it looks like, this was kind of a trick question, which has the greater surface area? It looks like they are identical. Now here's the way I would do it, is I would actually build it and count to be sure. So 1, 2, 3, 4, 5 on the front, 1, 2, 3, 4, 5 on the back. Counting this part, we got 1, 2, 3, 4, 5, 6. And then counting this outside, 1, 2, 3, 4, 5, 6. So there's your 5 plus 5 plus 6 plus 6 that we had done here. This one, a different way we could have found the surface area is we could have looked at each arm. And for this black arm right here, this one right here, we could have said there's 1, 2, 3, 4 going around plus the edge is 5. So this has 5 square units showing of surface area. So this one has 5, this one has 5, this one has 5. So that's 5 times 4 is 20, plus this green guy has a top and a bottom, and there's our 22. So we could do it physically, or we could do it with that picture. Definitely not using a formula right now, but we're trying to get the meaning of surface area. So let's get back. So it says the regular prism, number 4, a regular prism is 4 units high, 2 units wide, 6 units long. What is the surface area in square units? So you might want to build this in GeoGebra, but I'm just going to kind of fake it with my drawing. And I honestly never know the difference between high, wide, and long. I kid you not. And I got my degree in math, so I think I'm okay. But I think, let's call it this. Let's say this is it. So here's our 4 units high, 6 units wide, and 2 units long. So what is the surface area in square units? So let's first figure out the area of the red part, the red face. And so when we look at that, it's 4 units high, 6 units across, so it's got 24 square units. So then let's take a look at the top. What is that top? Well, that top is tricky. It's got dimensions of 6 by 2, all right? So 6 by 2 means it's got an area of 12 square units. And then lastly, let's take a look at this side right here, the blue side. And we're going to say that that blue side has dimensions of 2 by 4. Right? It has the dimensions of 2 by 4, which means it's got an area of 8 square units. So we're going to take the 24, the 12, and the 8. I'm going to add those together, and we get, oh, gee whiz, 44 square units. But that's just the 3 sides that we could see, the red side, the green side, and the blue side. They each have a partner. So we're going to take that 44, multiply by 2, and we get 88 square units. Looking good. Draw an example of each of the following triangles on the grid. So this is a little bit of review. So we have to draw a right triangle with an area of square units. I'm going to let you remind yourself what is a right triangle and what does that look like? And we need to find the area of a square of that triangle in square units. Don't forget that the formula for the area of the triangle is base times height divided by 2. Or you could say 1/2 of base times height. So you have some choices. I'm going to let you work on that one. Acute triangle, same story. You have to remember what an acute triangle is, but you remember that the formula is base times height divided by 2. Now there's going to be some beautiful patterns, because are you noticing that they always have the area is 6, which means you can keep the base constant, and you could be keep the height constant as well, and then just move the point, the vertice for that top triangle. So one triangle might look like this, and then another triangle might look like this, and then a final triangle might look like some crazy triangle like that. So keeping the base the same and the height the same, but just moving where that top point is across the screen. And this kind of looks slanted. It's not supposed to look slanted. It was supposed to be kind of like flat right there. There, even better. All right, now find the triangle. Find the area of the triangle MOQ in square units. Now this is beautiful, because finding the area of MOQ, the triangle MOQ, that's tricky. That really is. But they're giving you a hint. Look at that. They're putting a box, a rectangle around it. And finding the area of the rectangle is really easy. And then it creates 3 simple triangles that you can find the area of and subtract those from your rectangle. And what's left will be the triangle MOQ. So you're going to find the area of MOQ by not finding the area of MOQ. You're going to find the area of the rectangle. You're going to find the area of these 3 triangles and subtract. Boy, that's beautiful. That's a good problem. And looking like our last problem, find the area of this shape. Well, we can use that same previous strategy if we want, and find the entire rectangle. And then we can subtract out the 3 triangle, find the entire rectangle, and then subtract out those 3 triangles. And that's going to leave this funky shape right here. But another idea, oops, that's not what I wanted. I wanted an eraser. And then another idea is maybe a little simpler on this one, is you could just cut it right in half. Find the area of this triangle, find the area of this triangle. Ooh, and you get some sort of funky face right there. Okay, that's a joke. Okay, so anyway, oops, dang. And you could find these 2 triangles right here and add them together, and that'll give you the answer. All right, I'm going to zoom all the way up to the top. I don't know why I needed to do that, but here you go. So that wraps up this lesson. It's grade 6, unit 1, lesson 12. We began by experiencing the idea of surface area of a cabinet, and we ended up with a very official formula. Find the area of the 3 sides you can see, add them together, and then multiply by 2. Thank you very much.